Recording in progress.
Andate a casa, non c'è nulla da fare. 25 anni fa, una diagnosi di distrofia muscolare di Duchenne.
È vero che i miei muscoli diventano sempre più deboli.
Una patologia degenerativa rara che colpisce i muscoli. Ma c'è chi non si arrende e fonda Parent Project. Intanto il mondo cambia e anche Parent Project cambia un po' il mondo.
Ringrazio Parent Project e le
L'ultimo anno finanziato da Parent Project.
Il project che ha
Obiettivi da raggiungere e dei traguardi da conquistare. Oggi, anche con la Duchenne puoi diventare ciò che vuoi. Come Luca.
Luca Puzzella, che ringrazio per essere qui.
Morire insieme, è una sfida già vinta.
I'm here to tell, the future is there.
Jacopo.
Alla Duchenne.
Matteo, Lorenzo, Luca, Samuele, Francesco e come tanti altri ragazzi che vivono una vita piena. Ma questo non basta, non c'è ancora una cura e tanti sono gli ostacoli da superare e le strade da aprire.
tutti insieme.
Ma abbiamo formato una grande famiglia.
Scrivi i prossimi 25 anni di storia insieme a noi.
Eccoci qui, buongiorno a tutti dalla nostra
There
navicella.
we are. Good morning, everybody from our spaceship, and good morning to you all. We have had some problems of connection between open space and the Earth, so we are starting some minutes late. We apologize. We thank you. This is the third day of this 19th conference. This is a journey that started 25 years ago, and that, well, this year we decided to bring to the space. Today, I mean, it's a very dense day. We started on Thursday afternoon, and then we were together yesterday afternoon, and today we'll be together till 7:30 p.m. I wish to thank, first of all the rapporteurs, that are connected with us from all over the world. Well, this year we meant to have a face-to-face meeting, and we thought that was possible till, let's say, a month ago, and then we were obliged to cancel the face-to-face conference, and that is why we decided for this spaceship, so that we can see everything from up above. And I'd like to thank all those who have been devoting their time for many, many years, or even for shorter times. And we do hope and we want the international community to be better informed and start and join us rather in this journey that for us started 25 years ago. We are speaking of an international conference thanks to wonderful people who have been working for us for many years. Our interpreters are here with us: Vanna, Simonetta, Paola, Gabriella, and Valeria. They have been following us. They are translating for us all the sessions. And so a prayer to today's speakers and tomorrow's speakers, please do speak slowly so that interpreters can translate you as faithfully as possible. And now I'm going to explain how you can get simultaneous interpretation. Here you see the slide showing you how you can choose the language. There is this interpretation icon, then you see this image, and you decide if you want to listen to the conference in English or in Italian. Special thanks to our sponsors, elite sponsors, PTC Therapeutics and Italfarmaco, and our platinum sponsor, that is Sarepta Therapeutics. But we also wish to thank all the companies that, by supporting us, make it possible for us to organize this event, which is really essential to our community. And now, thanks to Parent Project staff, because for months now, they have been working for making all this possible. You have met some of these persons on Thursday and Friday, and you'll meet others today. There are many who are behind the scenes. There are people who contributed also to, well, restoring this connection with the earth this morning, because we had some minutes of utter panic because we were unable to connect. We have a service enabling us to do all that. So we wish to thank Carlo and Cleverage staff for making all this possible from the technical viewpoint. Before giving the floor to Gloria Antonini, she is one of the biologists of the scientific office, and Paolo De Leo, who is connected from home and is one of the member of the board of the Parent Project board, and he is one of the parents guiding the activity of Parent Project. It has been like that for the last 25 years, and this is really one of the achievements of this association, because the management of the association is in the hands of parents, and this is essential. So the first session that will be introduced by Gloria and Paolo, this is a session we are very keen on, and we'll be speaking about the scientific projects funded by Parent Project. And so for us, it is extremely important to give this contribution to our community. And we wish to thank the rapporteurs who are here with us and who are the real actors in these projects. They'll be telling us what they are doing and how far they've gone. And now, very shortly, just to very briefly to tell you something about the day's activity. The poster session will be starting at 12. We have posters that have arrived, and I mean at 12 we will have this 1-hour session for posters, and you'll be able to ask questions to the people who presented these posters. Then we have a break from 1 to 2 p.m. and we resume the session at 2 p.m. with another scientific session, much awaited for, that has to do with gene therapy and all that is going on in that area all over the world. This session will close at 3:30 Q&A, with a Q&A, and we'll be here to answer the questions till 4 p.m. And then at 4 p.m. we have a round table, so on everyday life. This round table, the title of this round table is How You Build Autonomy for Our Patients. This roundtable will go on till 5:30, and then at 5:30, a new scientific session is going to start on gene correction. And then this will go on till 7:30. But we also have a parallel starting at 6 p.m. and that is devoted to young adults with Max Olivieri, who will be speaking about affection and sexual life. So this is an overview of the day. I wish to thank speakers once again, and now I give the floor to Gloria Antonini and Paolo De Leo for who will be chairing the session. Thank you, Cristina. Thank you all for being with us. We have some small connection problems. It is a great pleasure for me to chair this session together with Paolo De Leo. He is one of the members of our board, and he is responsible for the activities of the science area. And of course, he gives us his opinions together with Magnano and Buccella. The support to research is an essential objective for our association, and it has been like that for a very long time. Well, we want rapid research. A parent project has been funding research since 1999. From 2005 to today, we have devoted to research 5 million euro, and that, 3 million euro. And if we add that up to what happened in the past years, well, we are beyond 4.5 million euro. And it is a huge amount of money if you consider that this is just a parents association. In 2018, we launched a new way of selecting projects. Two types of calls. We have a grant application and fast track application. The tender was opened in July 2019 and was closed in September of the same year. The maximum amount is 80,000 euro. And the association carried out two types of assessment, an internal one by the board and by the biologist, and then another evaluation, an external one, so a true peer review, and that was done by 3 international experts who evaluated these research projects, these research proposals. We range from basic research to applied research, so also clinical and diagnostic. The fast track tender was imagined for projects below 20,000 euro. It is a fast procedure, and this faster procedure was carried out after a selection of projects by the board and by the science area, depending, of course, the judgment was based on the feasibility also of the project and the area of research. Paolo will be introducing the rapporteurs of the session. Paolo, thank you for being here with us. Hi, Gloria. Welcome you all. And now I introduce Mrs. Elisabetta Ferraro from the University of Pisa, Francesco De Santo and Alessio Porcinaro. They belong to the CNR, the National Research Council. The project is fighting inflammation in DMD, modulating macrophage by a metabolic approach. You have the floor.
Eccomi, vedete?
Thank you. Can you see me?
Sì.
You see the screen? Okay, perfect.
Intanto voglio ringraziare
First of all, I'd like to thank Parent Project for having given us this opportunity. Our project, or the concept of our project, was to act on metabolism, but not that of muscular fibers, because in this that's not involved, but macrophage metabolism, which is involved in this illness.
Infatti noi sappiamo che
as a matter of fact, we know that macrophages are cells of the immune system that are very important in a damaged muscle because they orchestrate an inflammatory response, which is massive, but it has to be there.
Infatti questi macrofagi pro-infiammatori
These pro-inflammatory macrophages are replaced very rapidly by a subpopulation of macrophages that are anti-inflammatory and pro-regenerative. Now, this alternation, the sequence, doesn't happen in the dystrophic muscle in which pro-inflammatory macrophages, which are defined as the M1 population, persist. And so we have an inflammation that is constant, which is obviously detrimental to the muscle. Now, these two populations of macrophages are different for different reasons. And simplistically, we might say that they activate two different type metabolisms. A type M1 macrophages prefer a glycolytic metabolism. Type 2 macrophages instead prefer a mitochondrial oxidative metabolism. Our idea was therefore to act on the metabolism, try to stimulate mitochondrial metabolism so as to foster the presence of anti-inflammatory macrophages to the detriment of inflammatory type macrophages, so as to counter or fight the inflammation and foster regeneration of the muscle at the same time. It is for this reason that we chose 5 molecules that are known to have the ability to foster mitochondrial oxidative metabolism, and we tried to assess whether they could have an anti-inflammatory effect. The molecules we tested are riboflavin, vitamin B2, and idebenone, which is an analog of coenzyme Q10. They're fundamental to our metabolism. They exist in our cells. Then ranolazine, trimethazine, and mildronate, which do not exist in nature. They're synthetic, and they were approved for human use in cardiology against angina pectoris. All of these molecules were approved for human use. So in the case of muscular dystrophy, we would have to reposition the molecules. So we took the molecules and we started to test them in vitro first and foremost. So we took macrophages, murine of mice, we put them in culture, and we tested them with a lipopolysaccharide that induces pro-inflammation. So you see these macrophages start releasing cytokines. In parallel, we did the same, but together with macrophages and LPS, we also used the substances that we wanted to test one at a time to assess whether they might inhibit the release of cytokines, inflammatory molecules. So we observed this inflammatory effect for ranolazine, for idebenone, for riboflavin, and ICAR we used as a control molecule because we know for ICAR that we have this anti-inflammatory effect. Riboflavin, in addition to having an anti-inflammatory effect in vitro, also induces molecules typical of T category M2 molecules. As regards instead mildronate and trimethazine, pardon me, we did not observe any in vitro effect. So we selected these 3 molecules that you see right here on the screen, and we started testing them in vivo. Of course, in the typical mouse model of Duchenne, it's the MDX mouse. We chose a riboflavin and the other one. How did we do the experiments? Well, we did 2 types of treatment, one short, one long. For the short treatment, we started treating the mice at 2 months of age for 1 month, and then we analyzed the findings. As to the long-term treatment, we did the very same thing, and then we discontinued, and then we continued with treatment periods of 2 weeks every 2 months up until 9 months where there's greater damage. And so we analyzed the damaged muscles. What was it that we observed? Well, with regard to riboflavin, the short treatment, we observed, first of all, an increase in these fibers, the fibers of oxidative metabolism, which really do increase as a result of treatment. This is interesting because these oxidative fibers are considered to be more resistant to several stimuli compared to the other fibers. Here, there's also a reduction in fibrosis indicated by the staining in red. And there's also a reduction in the expression of collagen, which is a main component of fibrotic tissue. We also observed that the inflammatory infiltrate is reduced following treatment, and we wanted to understand the ratio between M1 and M2 macrophages in the infiltrate. So we did tests, and we're continuing to do them, and we observed that there is definitely a reduction of the TNF alpha, which is a pro-inflammatory molecule, whereas arginase, which is a marker for M2 anti-inflammatory macrophages, does not really increase as we would have expected and wanted, but tends to decrease with this short-term treatment. As to muscle function, which we assessed with a mesh test, in other words, assessing the ability of mice to hang on to a grid, we saw that there was an increase, but it wasn't significant. What happens with a long riboflavin treatment? Again, an increase in oxidative fibers, a decrease in fibrosis, a decrease in the inflammatory infiltrate, and from a molecular point of view, we observed a great increase in anti-inflammatory arginase markers and CD163 with a reduction of interleukin beta. One very interesting finding is that following this long-term treatment, there is a sharp reduction in these red fibers, which are the damaged necrotic fibers. In parallel, we also observed a sharp increase in muscle function, which seems very important and significant to us. What happens instead following treatment with idebenone? Following short treatment, no difference between treated and control mice. In spite of this, however, we decided to go ahead with the long treatment as well, because we did experiments on human macrophages in culture, and we observed that growing concentrations of idebenone reduce inflammatory cytokine very markedly, much more so than in murine macrophages. So we tested idebenone after a long-term treatment. We noted an increase in oxidative fibers, although it was less vis-a-vis riboflavin, a reduced fibrosis, but we didn't observe a reduction in necrotic fibers. Especially, we saw great variability. I'm going to show you the individual mice here, just to point out that some of them don't really show a decrease in necrotic fibers, but others do. There's great variability, which does not make it possible to achieve significance with this type of treatment. In spite of this, however, on the whole, muscle function of the mice increases. So we might say, in conclusion,
ha mostrato degli effetti
that
interessanti
riboflavin
riguardo
definitely had interesting effects, both with regard to muscle function and with regard to cytoarchitecture of the tissue. We therefore believe that this is a molecule that ought to be taken into consideration by our colleagues to assess possible clinical observations, because this is a molecule that has been approved in human use, also at very high concentrations, which is what we used in our experiments. Of course, we need to continue to study its effect preclinically, because there are no trials that concern riboflavin in DMD. And so it might be interesting to assess the effect of riboflavin after long and continuous administration. With regard to idepanone, findings are less evident with regard to riboflavin, and there's great variability. And although we know that there are clinical trials with idepanone that were discontinued, we do believe that we shouldn't abandon the study of this molecule altogether. Maybe we should look at different concentrations and different modes of administration. Also, bearing in mind the effect that this molecule has on other types of macrophages, for example, other cells. In other cells, the concentration of idepanone can be very significant and can harm cells. To conclude, I'd like to thank all those who contributed to this project with great enthusiasm and dedication, overcoming all the great difficulties we experienced in past years. Sara and Ariane in the lab, and our co-workers, especially Dr. De Santa's group at CNR in Rome, Chiara, Alessio, and Sabrina, whose role was crucial to the development of the project. I also would like to thank Professor Giulia Freer and Dr. Giulia Luttini for experiments on macrophages, and thank you all for your kind attention. Thank you, Dr.
Thank you. And now we give the floor to Dr. Caretti from Milan University, a new epigenetic approach to improve muscle homeostasis in DMD. Thank you. Well, first of all, I'd like to thank you all for supporting this project. And here, well, we know that our DNA in the cells is not linear, is not a linear filament, is not, it is wrapped around proteins, histones that affect the expression of genes. These histone proteins can be modified, and these modifications may favor or slow down or hinder gene expression. So we can consider these changes as a sort of switches that can switch on, switch off, or modulate the levels of some gene products. The modification promoting gene expression, such as acetylation, or if there are modification preventing, hindering gene expression, we have proteins, enzymes that write these modifications. We call them epigenetic writers, and there are erasers, epigenetic erasers capable of erasing them. And we are interested in a third category of proteins that can read the signals, interpret them, and translate them in a transcriptional response, modulating gene expression. We are interested in this family of proteins that has a domain there. So these are the BET proteins, the protein we are studying is in fact BRD4, has this bromo domain. So these proteins can recognize this acetylated histones, and they can promote transcription. Some years ago, an inhibitor was developed. This inhibitor is called JQ1, and it can prevent the association of proteins with a bromo domain with acetylated histones, because here in orange you can see them. There is a competition with this binding. And so proteins such as BRD4 cannot associate, and so transcription doesn't start. As you see in this table, there are other inhibitors of BET proteins that are used at present in clinical studies, and these inhibitors were initially developed as anti-tumor agents, and they are used in a number of clinical trials for both liquid and solid tumors, but also for cardiovascular diseases or metabolic diseases such as diabetes. Why we imagined that this inhibitor could improve the situation in Duchenne muscles? Well, BET proteins promote inflammation. And if we have a pharmacological inhibition of these proteins, we can reduce the level of inflammation. Former studies in an experimental model of tumor cachexia had demonstrated that BET proteins were important regulators of genes involved in muscle. And so with these two co-workers of mine, we decided to treat the MDX mouse with Duchenne with this dose of JQ1 for 2 weeks. And there was a morphological improvement of the muscle. So there is a reduction in centrally nucleated fibers, so a reduction in the regeneration cycles, and also a reduction in the inflammatory infiltrate that you can see in the MDX muscles there, and it is lower in the treated sample. In this muscle, you have a reduction in the permeability to this dye. You see the red, if you compare the treated with the non-treated, there is a lower tendency to muscle damage. From the functional viewpoint, we observed that treated mice, this is the red line, they had a performance that was better than the one that had not been treated, that had been given just the vehicle. And the same goes for the other functional tests. And this effect, this difference is maintained for some time also after the treatment was discontinued. We wondered what was the molecular mechanism that caused this improvement. As you know, without dystrophin, if there is no dystrophin, there is an alteration of various metabolic events. For example, increased susceptibility to injury, increased CO2 influx and membrane permeability, oxidative stress. But what of the initial events? of muscle damage is precisely the increase in oxidative stress, which is then linked to other alterations such as inflammation and fibrosis. So you have a more fragile sarcolemma, cell damage pathway activation, and muscle degeneration. Since this is one of the initial events, we studied oxidative stress in the MDX mice, and you see that there is an increase vis-a-vis the control mice, but after the treatment, there is a reduction in oxidative stress in the muscle. In parallel, we also see a reduction of the inflammatory infiltrate. We can follow that. Well, you see where it is brown, well, that is more marked in MDX mice, and it is reduced in the other samples. And the same goes for the fibrosis level. In the muscle, the main source of superoxide, which will cause oxidative stress, is precisely this enzyme, NADPH oxidase. I mean, they are all on the membrane in different positions and different areas of the muscle. And we checked whether JQ1 could modulate the levels of the different subunits of NADPH oxidase. Here in green, you have an increase in the transcript and in the proteins of NADPH oxidase subunits. After, with the treatment, there is a reduction in these subunits. And this is also observed in immortalized cells coming from myoblasts. So it is also present in a human cellular model. To better understand why we have this reduction, we carried out an experiment enabling us to follow the recruitment of the BET inhibitors on the genome. And we saw that the increase in the binding of BET proteins to the regions regulating the expression of subunits is increased in MDX mice, but after treatment, there is a reduction in the association of BET proteins with DNA, which might explain the reduction in the levels of the different subunits, which will lead to a possible reduction of oxidative stress. Conclusions. This BET proteins, BRD4 and BRD2, can modulate the expression of NADPH oxidase, and when there is no dystrophin, NADPH oxidases increases, and by doing that, it increases oxidative stress, and it triggers a number of events that lead to muscle damage. But with this inhibitor, with this BET inhibitors, we can reduce this NADPH oxidase, and by doing that, we can slow down the negative effect on the muscle. I wish to thank all of you for your attention, and the members of my group and all the co-workers, and of course, our sponsors. Thank you.
Prima di passare la parola al prossimo relatore, ricordo a
Thank you.
tutti.
Before we give the floor to the other speaker, to the next speaker, I'd like to remind all participants that if they so wish, they can ask questions by using the button on the left. And from the University of Milan, again, I'd like to give the floor to Dr. Messina, who'll speak to us about her project called Inhibition of the NFIX inhibition factor. as a form of a therapy for muscular dystrophy. Thank you. I hope you can see me
Sì, dottoressa.
and you can hear me. Well, the sound is not very good, says the interpreter. First of all, I'd like to thank Compare Project for supporting me on this pilot study that was funded with a fast track grant. What we tried to develop or assess was the possibility of reusing a drug conceived and approved for clinical use in cancer patients, even children, in muscular dystrophy, starting with studies in the lab that aim at targeting a protein called NFIX. In this brief introduction, I'd like to describe a rationale. A lot has been said by previous colleagues, but I'd like to stress that you all know, essentially, that at the basis of the physiopathology of DMD, we've got this cycle, this vicious cycle of regeneration and degeneration of the muscle, which is really important because it allows cells to be constantly replaced following necrosis. But we know that with the passing of time, there's a depletion of cells of the muscle. New fiber is no longer produced. And so we have the greatly feared adipose fibrotic tissue that's developed. This is a huge hindrance, not only to the life of the patient, but also for any approach. So any cell therapy or gene therapy approach can work, but they need to be able to work on an integral muscle to do that. Otherwise, they won't work as well. And that's why a lot of research approaches in DMD are focusing on increasing regeneration and muscle mass through different molecular or pharmacological approaches based on the basic idea that increasing muscle mass can slow down the degeneration of muscles. A lot of studies were conducted, the most important of which and best known is anti-myostatin, but we know that in the long term, these trials never led to the results that were described in the literature on mice. In the lab, instead, we went the other way. We wondered whether we should not perhaps not think about blocking degeneration, but rather slowing it down. And also, as was previously said by colleagues, it's known that slow twitching regenerating fibers are those that degenerate later on, these muscle fibers, because they usually function in a highly oxidative environment. So we wanted to assess whether converting dystrophic fibers into slow regenerating fibers might not benefit the patient more and protect dystrophic fibers. To do that, for some years, we have now been working on a protein called nuclear factor 1X NFIX, which plays different roles. And in the skeletal muscle, both in normal development and regeneration of the muscle. We wondered whether targeting this protein NFIX might benefit DMD or muscular dystrophy in general. This is a trial that we published in 2017. We used a dystrophic mouse model that was very stringent, and we used NFIX, and the absence of NFIX in dystrophy is of benefit, not only because it allows for morphological recovery, and not only does it reduce fibrous tissue, but it also allows for functional recovery, because we carried out several assays, functional assays, and we realized that a slow twitching mouse reacts this way in this context. There are different molecular reasons for or motivations for this. And in some work that we did, we observed that this happens because NFIX activates the transcription of several genes that regulate oxidative metabolism in muscle fibers and the inflammatory process as well. So eliminating this protein allows for a benefit for morphological and functional improvement of dystrophic muscle fibers. What we're now working on in our laboratory is the development of an approach which is very broad and multidisciplinary to inhibit NFIX. First of all, the message we want to get across is that we need to try to convert slow fibers and not block, but slow down the regenerative process of muscle fibers. With any approach, both metabolic or pharmacological, but this has to be our goal. Obviously, we want to do this through a pharmacological approach in so much as possible because it's easier and the modes of administration are a lot easier too. But we have to know our enemy in order to achieve that. In other words, NFIX. What do we know about NFIX and what don't we know? Unfortunately, we know very little. We know its biological role, we know its function in a healthy context and in dystrophy, but we do not know a lot of aspects of the protein, who upstreams it, who downstreams it, what is a pathway, biochemical features are not known, we don't know the DNA binding mode or its structure. All of these aspects are something we're investigating right now because we're interested in looking at the regulation and expression and the function of this protein. We're now trying to define its structure as a protein because we realize that if we're familiar with its protein structure, then we can design drugs so that selectively and specifically can target the protein in question. These are very lengthy and time-consuming studies. So we are trying to speed up other types of studies, one of which is based on our understanding of the molecular mechanisms that regulate NFIX. In 2018, we published an article and we observed that ERK, which is involved in different biological processes, ERKs are indirectly responsible for NFIX gene expression, both pre and postnatally. Indeed, the inhibition of ERK with a special drug can inhibit ERK kinase and can impact the NFIX protein expression. Therapeutically, we thought this was extremely interesting because ERKs are very active in cancer, and there are several drugs that inhibit ERKs for cancer patients, including children. Of them, tramitinib, which seemed to be very interesting. So we gave funding for this pilot project, the main aim of which was to inhibit NFIX in dystrophy and therefore improve morphologically and functionally the conditions characterizing the illness. These are in vivo data because we, of course, tested tramitinib in vitro, and we looked at the inhibition of ERK. We observed a decrease in NFIX, and therefore, in vivo, the final target was to assess the improvement in dystrophic phenotypes. What we did was to treat mice, dystrophic mice, MDX mice at 5 weeks. That is a time in which the pathology is very intense, very strong, and we treated them with oral gavage for 14 days. at different doses. And then we sacrificed the animals and we looked at the morphology and functional recovery, if any. The first aspect was to assess whether there might be evident side effects following the treatment. Of course, cancer patients had shown non-toxicity of the drug, and no motor problems or muscle problems had been described in these patients. Of course, we had to further assess that. Now the animals treated with the different doses gain weight normally, they grow normally, they have no problem in food intake, so no great adverse effects were observed. Then histologically and through Western blot, we assessed the efficacy of treatment in inhibiting the ERK and therefore reducing the expression of NFIX. These are dependent mice that were treated, and we observed that especially at 6 milligrams per kilo, but also at 3 milligrams, there is a good inhibition of ERK and an excellent inhibition of NFIX. When, however, we assess the morphology of treated mice, surprisingly, we observed these calcified fibers. Obviously, they are not present in untreated dystrophic mice. They are instead very evident in mice treated with 3 milligrams and 6 milligrams. And these prevail in diaphragm and less so in the tibial area in mice treated with 3 milligrams. Now, this really surprised us. In a more targeted assessment, we gained confirmation of the fact that the fibers were calcified. This is the tibia region of the mice, and we saw that at 6 milligrams per kilo, the treatment leads to a calcification of the tibia in the mice. Obviously, this was a great obstacle to our study, but the study itself had this very purpose, i.e., not just to inhibit NFIX, but to see whether there was an improvement in morphology and in the function of the muscles. So what we did do was to treat MDX mice as well, not just the SGCA mice, and the calcifications appeared in them as well, but not in wild type mice. So the inhibition of ERK in wild type subjects does not lead to calcified fibers, whereas these fibers do appear in the other cases, i.e. in dystrophy, which can be observed, but that explains why we hadn't observed anything of this kind in cancer patients. The mice are moving around normally, they're well. These calcifications do not seem to entail huge motor problems or mobility problems, depending upon the state of dystrophy, obviously. But this greatly slowed down our study, you will understand. These are just some of the images that I wanted to show you. Clearly, this did not make it possible for us to conduct a simple analysis to assess the morphological and functional improvement in the mice, because the presence of these calcified fibers prevents us from conducting an adequate analysis. We don't even know the nature and the biological reason for these calcified fibers, and so it's very difficult. You see that the fibrosis has not lessened. The infiltrates, inflammatory infiltrates, have not improved either. We observed a slight increase, but not significant, of oxidative fibers, and we did not see an improvement in motor function at this stage. So obviously, the finding that was very unexpected can lead us to this conclusion. Our study isn't over yet because COVID really did slow things down a great deal. But anyway, at this stage, we can say that trametinib is efficacious in the reduction of NFIX protein levels. But at these doses, because of the calcification that we've observed, we cannot assess the efficacy of this in dystrophic phenotypes. At lower doses, there is no calcification of the fibers, and so we have to understand what happens. And the other thing we want to do is to try to treat mice that are pre-symptomatic, not at 5 weeks when the pathology is very evident, but right after weaning, to try to understand whether there is a problem there. I'd like to thank my research group and of course parent project that funded this pilot project or pilot study, especially Giuseppe Angelini, who began the study with great difficulties because of the pandemic. And I thank you all for your kind attention.
Grazie, professoressa Messina. Ricordo solo a tutti i relatori di parlare più lentamente, così da poter facilitare l'uso.
Please speak more slowly for the interpreters, but also don't move in front of the microphone and don't gesticulate if you're using the microphone of a PC. The title is Phenotypic Variability of Bmd. Proposal of a clinical characterization protocol to stratify patients. It was a clinical project aimed at BMD, and we know that BMD is far more common than DMD, and it is characterized by lower seriousness and a maximum of clinical variability. But there are very few, there isn't very little information as to scientific findings and clinical consequences to try and characterize this variability and obtain important elements, especially considering if it is possible to treat them and to carry out clinical trials in this respect. This is important. This led to the planning of a study which during the evolution of the disease, we decided to apply clinical and instrumental assessment methods, and by doing that, trying to understand what is the evolution over time and what differences we may have depending on the genotype and phenotype present in BMD. So this is the pattern of the protocol we used. And we can see that the sample, the cohort was made up of 32 BMD adult patients, and we had a baseline assessment. So time 0, our patients, of course, were great. They cooperated with us. They were very, very cooperative, and we wish to thank them at the start. So we have a baseline neurological evaluation and also 2 systems of analysis that are that have become more and more prevalent for non-invasive assessment of BMD patients. And we are speaking of muscle MRI. And as for cardiological evaluation, MRI of the cardiac muscle. We follow these patients for 24 months. Let's say not for all of them, but for a subgroup. So, and then we stratified the results, also taking into account the difference in the duration of the follow-up. What did as results are concerned? Age between 21 and 70. I wish to stress that, of course, that means that there is a very strong clinical variability in the biological features. So we have tried to obtain a correlation between the genetic finding and the clinical finding, considering the different variables. The range, so the clinical variability ranged from patients who were totally asymptomatic from the muscle and skeleton viewpoint, so a very high variability, up to patients who around the age of 25 or 30 had already lost ambulation. And as for the cardiological phenotype, there again, there were substantial differences. In the correlation between genotype and phenotype, we can say that when the mutation started in exon 45, and when it extended more or less along the gene, well, in that case, there was a worse performance from the muscle and skeletal viewpoints. Whereas if the deletion only concerned exon 48, well, that was less severe as for the muscle and skeletal scores. Here you see the North Star ambulatory scale, and in the different patients, you see that this variability was correlated with two subclasses. So 45 exon mutation, and the other one where it included exon 48. And that also applied for the MRC system. Let's see what happened with NMR. It is a very complicated table. It gives you a general overview. So if the muscle was impaired, you see, well, that the score is in a darker area. And I mean, the color tends to the white as the muscles were not so seriously impaired. And of course, that is linked to the type of mutation. Two important muscles, proximal muscles of the pelvic girdle and the iliopsoas. You see that in the group of patients who had a deletion including exon 45, and here you see the severity of the symptoms, but the iliopsoas is not affected. And with other mutations, of course, things are exactly the opposite. Here we have, in a subpopulation, we obtained cardiac MRI. And here you see that the alteration in exon 48 well, that doesn't have a big effect on the heart. In this, we have seen two patients with dilated cardiomyopathy. And in some patients, in 10 patients, we have identified subclinical situations with involvement of the heart muscle and an inflammation in the areas that have been examined. Now, follow-up clinical data. But these data do not help us in this type of study. I mean, we cannot identify variations, substantial variations in the different elements and items that have been considered in the interval, in the time interval we were studying. So clinical data were quite stable during these 24 months, and the same goes for functional tests, motor tests, such as the 6 minutes walking test, but that also applies to NMR, as we see in the next slide. And apart from very, very rare cases, this disease is, well, luckily this disease is quite stable. It makes it necessary for us to identify more sensitive biomarkers to identify the small changes that obviously over time, I mean, that of course may be evident over a longer period of time to define the natural history of these diseases and identify different outcome measures for the different trials. This is a project, a satellite project that we devised together with the project funded by the DMD. This is InGene 2.0. And that was thanks to funding by the region of Tuscany. And the objective of this study is by using, well, we are using oncology algorithms. So the most specific BMD features, we want to identify variables. So by crossing genome data, clinical data, and also data of bioengineering. Here you see biosensors with which we try to quantify the functional and motor deficit, also in the cases of a very, very minor pathology, to try and define some outcome measures for future studies. Of course, we have confirmed the slow evolution of the disease, if not even a stable disease, but we must also stratify patients so as to precisely know who's going to have a more drastic evolution, and in all cases be ready for an approach to have the optimal design of the story of this disease. I wish to thank all my co-workers, and of course I also wish to thank Ferrin Project for supporting this project. Thank you.
Thank you. And now I wish to give the floor to Dr. Dorizio from the Bambino Gesù Hospital in Rome. She's been with us for a long time, and she's going to talk to us about her project about these in to the Good morning, everyone. Kindly take the opportunity to
Recording in progress.
Diciamo a fenotipo appunto ipocinetico, caratterizzato da una importante riduzione del muscolo in maniera progressiva. Infatti,
operates progressively. Indeed, based on our things, we know that in the course of time, it basically affects all patients with DMD and Becker muscular dystrophy, and the trend is quite slow over time, with a significant impact in terms of survival or to transplantation in BMD. So characterizing this cardiomyopathy is very important, clinically speaking, but for the whole neuromuscular community as well, because it's the first cause of death in these patients. And it becomes apparent in the second decade of life with a progressive trend. So in the natural history of this disease, we know that the heart morphologically is normal, the muscle is normal, a fibrosis begins to develop. It's not identifiable with an ECG initially, but then the fibrotic replacement all the way so-called air. So as you can see in this image, it's a thinning of the muscle walls and immediate forms, which the fibrosis is still subclinical. It is characterized by an absolute reduction of the left ventricle. The other finding that we are familiar with is that this cardiomyopathy leverages on preventive strategies which use ACE inhibitors when the left ventricle function has been preserved. The specific aims of the study funded by Parent Project on a fast track basis is to identify the characteristics of the ventricle before ACE inhibitor therapy is commenced, and to establish correlations with ECG changes, which are typical of this illness. And another aim is to identify with metabolic markers and proteomic markers the progression of the left ventricle, so as to
stadio di patologia.
identify progression from one stage of the disease to the next through a correlation with the echocardiographic and clinical profile. We've only done the first part of the study and identified only cardiac atrophy. The study was conducted on a retrospective group of patients referred to Bambin-Gesù, and we analyzed the condition of patients under 10 years of age who did not have the typical characteristics of dilation. So in their case, the ventricle had essentially normal size with also a normal ejection fraction. These tests were conducted before a treatment with ACE inhibitor, 1 year after the treatment, and at the last follow-up. The study is very simple, really, because we used echocardiography that made it possible for us to identify cardiac atrophy. Cardiac atrophy involves the remodeling of the left ventricle, and we observe a reduction in the muscle mass correlated with age, gender, and systolic pressure. And it serves the purpose of identifying the early mechanisms that lead to the impoverishment of the muscle mass of the left ventricle. We enrolled 45 patients. The average age was around 10 years, whereas the average age at the beginning of treatment with ACE inhibitors was 11 years. 72% of our patients presented cardiac atrophy at the first cardiological assessment before 10 years of age, so before therapy with ACE inhibitors. And this type of analysis was also done during follow-up, and it was shown that 9 patients developed cardiac atrophy a lot later, and in 6, it was possible to actually report a regression. We did not observe
una significativa progressione
a significant progression or regression in all the groups in which cardiac atrophy was identified. And with regard to the ACE inhibitors, well, we reported on the differences of the prescription of ACE inhibitors in our case series, and we showed that half of the subjects were treated with enalapril and not the other drugs that were reported in the literature. A year after treatment with ACE inhibitors, the percentage of patients with cardiac atrophy was unchanged. And over time, 6 progressed and 6 regressed. Therefore, the data suggested that cardiac atrophy as a process is already present under 10 years of age, and that therapy with ACE inhibitors might be able to slow down the atrophy process, but not significantly. Thank you very much for your kind attention, and I will be very happy to answer any questions you may have. Thank you. Thank you very kindly to all of the speakers. We had a few audio issues. I'm very glad that the technicians helped us out. Thank you, Paolo, for having co-chaired this session with me. And now it's my pleasure to invite Ilaria Zito to join me here. You saw her yesterday, but we can begin the question and answer session. We have one initial question from Viviana. She says, good morning. This is a question for Dr. Ferraro. She says, obviously starting with the rationale of affecting macrophages. In vivo, the whole of the body is affected, and there's a metabolic shift. Did you think about targeting only macrophages and then transplanting them in vivo to see how their metabolic shift contributes to the pathology? Can you hear me? Yes, thank you. Thank you, Viviana. Yes, I think that it's very interesting what you're suggesting, especially to find out the underlying mechanisms of the pathology. We know that it's crucial for future prospects. Therapeutically, we know that therapy and the fact that it can have this effect on fibers is a positive finding. It's a very positive thing that mitochondrial metabolism in fibers especially can be stimulated. So I think that it would be very interesting to do this to better understand what's going on. Although technically, I think it may be quite complicated because macrophages are very plastic cells, they're very sensitive. And even isolating them activates them and it changes their phenotype. So we really need to think about the feasibility of this from a technical standpoint. If I might add something that goes in this direction, maybe not so specifically, but we are thinking about doing something in collaboration with a group from the University of Pisa. We're thinking about using biodegradable polymers with substances of interest and doing a local administration to look at the specific effect that they might have on the skeletal muscle. Not only that, because a molecule circulates anyway, to understand more specifically what is going on and to also test other administration pathways that might be more effective and efficacious. Thank you for that suggestion. We have a question again for Elisabetta Ferraro from Professor Claudio Bruno, who we'd like to greet. He thanks you, he congratulates you, and he asks, how did you administer the drugs to the mice? He says, I'm sorry if you may have already said that, but I didn't hear it. And did you assay the serum CK? Yes, intraperitoneally was the pathway, the administration pathway in both. No, to answer your question, we did not use that, but it's definitely something that we ought to think about, and thank you for that suggestion.
Thank you. This is a more general question. The question comes from Hungary. Could you share your slides in English, please? And then a question by Alessandra to Mrs. Messina. If the calcification of fibers can be considered a specific situation for mice, and what would you expect is going to happen in men, how that might change in men? Yes, we can hear you. Thank you. Thank you. Yes, I've read the question. Thank you for the question. Well, it is linked to the disease because when we treated the wild type, there were no calcifications. Occasionally, as especially the other model, they have a baseline calcification, but of course with this treatment calcification increases, especially in the areas where there is more necrosis. Calcification is linked to necrosis. If this happens only in the dystrophic mice and it doesn't happen in men, of course, we still don't know. We could know that if we were to treat patients, but we are still very far from that. Those who study these molecules in oncologic patients, of course, they didn't carry out any biopsy. It was done essentially in melanoma, in colon of the cancer and of the rectum. They only observed that patients have no alterations in motility or in patients' behavior. Well, in my opinion, it's one. I mean, when you carry out a drug repurposing, well, you then must go and check your tissue target. The pharmacokinetic of the drug was assessed, but in a different disease, it might have different effects. When we treat with Promethazine, when we treat wild-type mice who were subject to an acute damage, we don't see this type of alteration. So it is really the result of muscular dystrophy, chronic damage, chronic inflammation. So it is not correlated with the acute damage. So we don't really know what's going to happen in the dystrophic patient.
Bene, grazie. Speriamo di
Thank you.
C'è una domanda di Gianfranco.
Question by Gianfranco for Professor Siciliano. The study whether this also applies to nonsense mutation in BMD.
Eccoci qua. Direi che in principio sì, senz'altro.
Well, in principle, the answer is yes, because in the nonsense mutations, the variability that we may expect is greater, because we know that there are modifying factors also in terms of muscle and skeletal phenotype. They may play a role also related to the quantity and quality of the remaining dystrophin. So, well, we must carry out, of course, a proof of concept study and also study these patients. It is very important to follow that because these are possible parameters and outcome measures in view of therapeutical trials. Thank you. And now a question for Professor Caretti. Francesca is asking, have you evaluated the effect of the JP1 effect on other organs of JQ1 to exclude possible side effects of the treatment? It is an excellent question. No, we haven't done it yet. we want to see what happens in the heart. Other groups have carried out other studies using tumor models, pharmacokinetic and pharmacodynamic studies in different models, and no serious side effects were seen. But of course, you have to do that for this type to see if there is any specific consequence. One last question. I know that the answers have been given also in the chat, but we prefer to repeat them so we can all read them in Italian as well. For Mrs. Graziella Messina, the question is from Asma Russa. The question is about calcification. It also happens if there is no treatment in the mice. Maybe you can compare the gene expression in this model with the treatment with trametinib. An unexpected finding or a negative finding maybe may give us new ideas. Well, a finding is never negative. It's always a piece of information. Yes, we have tried, but because of course that was quite disturbing. Because of course we had different expectations and different objectives, but it was very interesting for all. I mean, this link existing there is, I mean, it might be interesting to see this link between ERK and calcification. It is alternative when fibers degenerate, you may have fibrosis or you may have calcifications. The inhibition of ERG kinase may lead other elements, or maybe satellite cells themselves, to produce cartilage or bone, promoting calcification rather than regenerating new fibers. If you were to concentrate on this effect, what you suggested is absolutely right. I mean, you would have to carry out a genomic analysis. But it was, for the time being, that was not our goal. Thank you, Professor Messina. We have a question for Mrs. Aldorisio, and now we close the session and then we reconvene for the poster session. A very clear presentation, thank you. Due to COVID and due to a number of bureaucratic obstacles, the project was started in a sort of clumsy way, but then we managed to do something for our patients. This metabolomic study, we'd like to ask, when are you going to reach your goal? Well, we have already enrolled half of the patients. So we expect to complete the sample by June, and then starting the data, let's say before December, we should have some results. Thank you, Rachele. I wish to thank all the speakers for being very clear. And I thank Paolo De Leo for being here with us. Now, I give the floor to our coordinator, Cristina. We are going to start the poster session. The poster session will start at 12. And so we thank the speakers of this first session on Saturday morning. Thank you for being here with us and for supporting parent projects for many years, projects, participation in our tenders, and also for being present also in our conferences, and of course also in preparing material for our families. Thank you very much indeed. And we'll have a short break before the poster session, but we also take this opportunity to speak about the material, the information material we produce. We have had some connection problems from our spaceship during the night and during the morning session. Maybe someone realized that there was some small problem. It's not our fault. This is linked to the net, and this morning the net had a few problems. So the part of the site devoted to the conference where we had all the new materials of the conference at present is not visible, but I just wanted to remind you all that during yesterday's parallel sessions, so as soon as the recording can be resumed, we published the QR code of the new material, domotic, for example, or other material on the material we have for siblings, for the siblings sector session. And this material will be sent during the session, and we have all the scientific material as well will be sent. Every year during the international conference, we produce and we update the pamphlet on clinical trials. The pamphlet is ready and it is visible, or rather it will be visible when the connection is resumed. And I take this opportunity also to say something else. We have thanked the sponsors, but as you know, Parent Project also has been surviving over the last 25 years thanks to well, private funds. And so we can develop all the activities also for the social and psychological support to families and the activity also of our scientific bureau. So I must well, do this type of promotion. We'll launch our Easter campaign very soon. It is for fund gathering, fund collection. These are Easter eggs. They are very special, not only because the chocolate is very good, but because these eggs support scientific research funded by Parent Project and also the activities that Parent Project has been developing over the last 25 years so that patients and families can live a better life and also support scientific research, also participating in this research towards the dream we all share. Every year, we have the possibility of choosing an organization for the 5 per 1,000 donation. And this year we have a very new material to promote the 5 per 1,000 campaign that has to do with income taxes in Italy. I like to invite speakers and all those who follow the activities of Parent Project. Well, please go to the website parentproject.it. And we had some problems there as well, but those problems were solved earlier on. And there you can find all the information to know how to support us. And it is really very important for all the people who follow our association can also participate in these aspects of fundraising. So we have a campaign, the Easter campaign for fundraising, and the 5 per 1,000 campaign to get information on how to receive the eggs. We try to send these eggs all over Italy. And also if you need information to fill in your income declaration, well, that of course is you must know what is our code to put the code in the declaration so that your 5 per 1,000 is devoted to Parent Project. We're going to start now the poster session. We are waiting for all the participants to connect. We had put the posters on the website so that they could be seen. We still can see you, and we hope to restore this connection. But I hope that the posters can be seen very soon in the afternoon or in a few minutes. They are working hard behind the scenes, and so we do hope that we can do that very soon. Then we'll have a break from 1 to 2, and then at 2 we resume with the third scientific session. And the chairperson will be the founder of Parent Project. He needs no introduction, certainly, Filippo Buccella, together with Fernanda De Angelis, who is one of our biologists of the science area. And they will be chairing a session that is one that is much awaited for, because that is devoted to gene therapy. And then we'll go on for the whole afternoon and evening. It is a very intense day. And after that, we have a round table, because Parent Project has invested over the year a number of resources in scientific research, but we also believe in another type of research. Parent Project has been working on sort of an everyday effort to try and find new solutions and new resources to well, coexist with the pathology, with the disease, to live. Is the role of Parent Project in Italy, but also in the world, has always been that of helping parents and patients themselves not to consider the disease as the protagonists of their life, of their lives. Of course, the disease is there. It is a very challenging disease in everyday life, but you must not stop there. So in this roundtable, we'll try and speak about possibilities of autonomous life for our patients. So we wish to invite you all, also those that are more keen on the scientific aspect of our activities. We ask you to follow, also to follow roundtables and the parts devoted to everyday life, and because they are very important. And we try to intertwine them with the scientific aspects. And by doing that, we hope to achieve a good quality of life for us all. And now now it is 10 minutes to 12. So in 10 minutes, we'll start the poster session. We remind all speakers that our conference is being simultaneously translated into English or in Italian, depending what is the language of the speaker. And for our interpreters to be able to do their job. And we thank the interpreters because of course they are online and they translate simultaneously different people who speak at speeds and that are of course different, and also technical situations that are different. And so please speak slowly so that they can do what they are expected to do. For those who have just come in, that to choose the language you want to hear, well, there is the Zoom bar and you click on the interpretation icon, you choose the language and you choose the language. You switch on the icon with English or Italian flag and you get the language. Maybe we can send our video again. We can broadcast our video again. And don't go away after the round table. You must always keep following us in the spaceship. You have 1 hour just to go and have a quick lunch. I know that there are some people who are in front of their TV and not their PC. And so some of you are watching us on the TV. Don't go away after the round table, because at 5:30 we have another scientific session that will be chaired by Ilaria Zito, together with another member of our board, that is Ezio Magnano. He is a Sicilian father who is a member, who has been a member of Parent Project Board for many years. And then at 6 p.m. there is a very important session for us and our boys, speaking, analyzing, considering also affection and sexuality of people who have DMD or BMD, and so a disability. This is devoted to young people with Max Olivieri, who is the president of the Love Giver Committee, and that he has also participated to our face-to-face conferences, and we try to work with him. The session will be chaired by him, will be devoted to him, so to speak, and chaired by one of our workers. I wish to thank once again all the people who are working and who have worked on this conference for so many months. Then the conference goes on just for 4 days, but we started working on that last summer. We started thinking about the program in June. There are some 30 people who work for Parent Project, 20 of us in Rome and 10 of us in different areas of Italy. And we tried to create a program that could mirror the needs and expectations of families, not only Italian families, but also families all over the world. And this work starts in this way and then is constantly submitted to our board. Our board is made up of parents who live in different areas of Italy. They have their lives, their job. They have 1 or more kids with DMD. And this is why they are those who manage the association. They say, it's okay, we can go in this direction. And for many months, we have been working to have this event face-to-face or hybrid at least. So the idea was that of organizing the meeting at the Argife Hotel in Rome, and we would have had a connection, also remote connection for those who would be unable to come. We worked as if that was going to be the case till January, when the Omicron variable started spreading, and then we had to stop and decide differently. And so the board decided, in order to avoid logistic problems linked to last-minute problems, we had to go for an online solution. So we had to imagine it all over because the program had to be modified. And so thank you. I thank all the speakers who accepted all our changes in the timetable, and of course we asked for the material. And now I believe we are very close to the poster session. I don't know what is the time. We'll be sending the images of our sponsors. We thank our sponsors because they make all this possible. Parent Project has always been working in a partnership with drug companies who decided to invest on research for DMD. But not only do they invest in research, but they also try to understand together with us what are the projects that can be developed so that the DMD and BMD communities can do better. Now, I think we have the online projection of the video. We try to prepare communication materials so that these pamphlets can reach you and enable you to increasingly better understand the story of our association and also the activities we develop. So now we have videos being projected by the service. See you.
Andate a casa, non c'è nulla da fare. 25 anni fa, una diagnosi di distrofia muscolare di Duchenne.
È vero che i miei muscoli diventano sempre più deboli.
Una patologia degenerativa rara che colpisce i muscoli. Ma c'è chi non si arrende e fonda Parent Project. Intanto il mondo cambia e anche Parent Project cambia un po' il mondo.
Grazie Parent Project e devo
L'ultimo anno finanziato da Parent Project.
È un progetto che ha 8 anni da studiare in maniera...
I pazienti oggi hanno un futuro da immaginare, degli obiettivi da raggiungere e dei traguardi da conquistare. Oggi, anche con la Duchenne puoi diventare ciò che vuoi. Come Luca
Buccella, che ringrazio per essere qui.
Insieme, è una sfida già vinta.
I'm here to tell the future is there.
Jacopo,
Alla Duchenne.
Matteo, Lorenzo, Luca, Samuele, Francesco e come tanti altri ragazzi che vivono una vita piena. Ma questo non basta, non c'è ancora una cura e tanti sono gli ostacoli da superare e le strade da aprire.
Tutti insieme abbiamo formato una grande famiglia.
Scrivi i prossimi 25 anni di storia insieme a noi.
Eccoci di nuovo. Buongiorno a tutti. Adesso cominciamo la sessione poster. I poster sono stati messi sul nostro sito. Speriamo di
we're ready to start the poster session. The posters were posted on our site. We hope to see them better. We thought that we would have a completely different setting in a big hall at the Ergifa Hotel in Rome, but that was not so. We had to rethink everything. We organized everything very quickly. So we'd like to thank all participants for adapting to this new setting and for joining us in this virtual session, which actually is taking place in outer space. It couldn't be more virtual than that. I'd like to thank all the staff that dealt with all the technical aspects and the website. This is a European project. It's called Renoir. It's financed by the European Union within the Horizon 2020 call, and it's coordinated by Professor Silvia Brunelli from the University of Milan. Bicocca. It's a multidisciplinary project which involves many stakeholders, members of academia, industrialists, and so on, that aims to study muscle regeneration of stem cells and aging. We're partners in this project. We had the great pleasure of hosting and working with 4 students, PhD students in this project, because the first aim of this project is to educate or train 4 young researchers. And because we are partners in the project, over the years, we're going to be able to host gradually all of these young scholars. In the past, we had Sarah Williams with us and Christina Gutierrez and 2 more, Felipe Ferreira being one of them. They greatly worked on the program of this conference, and especially they worked on the poster session. So I'd like to thank them very, very kindly. I also wanted to thank and introduce 2 members of the panel, of the jury, of the posters, who together with me assessed 19 papers. I'm talking about Francesca Ceradini and Silvia Bencivelli. Francesca is someone familiar to a lot of you. She was a member of Parent Project for many years, and now she's scientific director of the Osservatorio Malattie Rare, the Rare Disease Observatory. And the other member of the panel is Silvia Bencivelli, who needs no introduction. She's a scientific journalist and is also an anchor woman for TV and radio broadcasts. So thank you, Francesca, and thank you, Silvia, who I see on the screen. So if there are no questions from the audience, we will read some. Fernando De Angelis is right with me and has been here for many years. I'm the most senior. Welcome to everyone. And I'm glad that Gloria thanked members of Renoir. We greatly miss them, and we would have wanted them to be by our side at this conference because it's always wonderful to have them with us. And we'd like to welcome all the young researchers and investigators who have worked so hard to contribute to the organization of this conference, by sending their scientific papers, as they customarily do, but also by writing articles and trying to mainstream the essence of their research. This is what they endeavor to do. In other words, to convey the messages of the research in a language that could be understood by a lot of people, trying to strike a balance, of course, between scientific rigor and method and more mainstream information. I'd like to read out some questions that have that we've already received so that we can give these young researchers a voice. They're connected. The first is for Dr. Maria Sofia Balzerano, and it is a question that has to do with stem cells. Have you compared stem cells in healthy subjects against those of individuals with a pathology? Is she not here? Well, maybe we can move on as we wait for her to join us. Maybe we could move on to a different question for Dr. Kumbo. Many of you know her. She's been with us. She works at the Pediatric Hospital Bambino Gesù here in Rome. This has to do with her poster. What do you think would be the best educational strategy to follow to reduce the risk that patients with BMD develop learning disabilities? Dr. Kumbo. Yes, here I am. I'm sorry, but while you were asking me the question, something changed on the screen. Could you kindly repeat the question? Yes. Which do you think would be the best educational strategy to follow in order to reduce the risk that patients with BMD might develop learning disabilities? Okay, well, it is difficult to think in terms of a single strategy to prevent the evolution of dystrophy. What we can do, however, is to give advice to parents and educators and all those who work with these children, try to enhance their attention span, to involve them in different activities, try to stimulate them. And we also recommend that activities are undertaken in daily life that can involve and increasingly stimulate their attention. Obviously, this ought to be done in a gradual fashion with increasingly complex phases according to neurocognitive development and according to the activities that can be engaged in with these children. Thank you, Dr. Kumbo. Do you think you're going to continue the study by enlarging the BMD patient population or not? And we ourselves, as an association, were wondering whether we could help you with that. The answer is absolutely yes. This is one of our goals, i.e. to try to enlarge the patient population. This is a goal we're pursuing with Dr. D'Amico and Dr. Tosi as well. It's definitely one of our aims. We also want to assess, as was done for DMD, a longitudinal evolution. We want to see how these characteristics evolve over time. So this is something that we are already thinking about working on. It's actually in progress already. Of course, working together with you would make things easier, and we could definitely discuss this further together with Dr. D'Amico as well. Thank you, Dr. Kumbo. I think Dr. Falcarana has joined us now, so let's reread the question. We're sorry, but the speaker is not very audible. Have you compared urinary stem cells with stem cells of healthy subjects? There's an audio. You need to unmute your microphone. Can you hear me now? Yes, we can. Yes, we compared and characterized urinary stem cells of healthy subjects against urinary stem cells from patients. Our study started out with the characterization of DMD patients. So we used cells from DMD patients for different purposes. Both to determine whether they were a good in vitro model to evaluate the diagnosis and to characterize the types of transcripts and proteins that are produced by this cell type. Obviously, as a control, in order to be able to compare the different aspects, we used donor cells, healthy donor cells. Thank you. And now Gloria will take on the next question. Yes, this is a question for Dr. Zambon. And here it is. What is the impact of the study on the decline of respiratory function in DMD? Dr. Zambon, first of all, thank you for being with us. Good morning or good afternoon, and thank you. The study that we performed looks at two important issues. On the one hand, the decline of respiratory function, how that correlates with the onset of sleep and respiratory disorders. With regard to respiratory function, the sample of the population is described in the literature. We know that respiratory function can be measured with different instruments, including FBC. And FBC, the percentage of FBC compared to healthy subjects of the same age and the same gender. From 10 years on, we know that there's a decline. And an interesting finding that we observed is that in a population of patients of about 20%, the trend is not necessarily linear. In some subjects decline more rapidly than expected after they stop walking. And this is really important in order to interpret the findings of clinical trials. And then the goal of this, the purpose of the study was to assess, to see how this decline correlated with the onset of several disorders, sleep disorders, but especially hypoventilation at night, which means when at night CO2 levels grow. CO2 is one of the two gases that we exchange when we breathe. We bring oxygen into the blood and eliminate CO2. Did I answer? Yes, very clear, Dr. Zambon. Thank you. Thanks very much. Another question is for John McKenna, who should be with us, I hope. We should be able to see him. There he is. Hello. Hello. I'm going to ask you in Italian. I'm sure that you will hear the simultaneous interpretation into English. The question is, registers, with patient registers that collect genetic and clinical information for BMD and DMD. These registers came into being in 2008. The question is, what has changed over the years? Have many things changed since these registers are kept? What has changed in that domain?
Well, since 2007, since the first data set was published, there have been a lot of advances in therapies, genetic and otherwise, in DMD and all neuromuscular diseases. And so the data set has been updated in 2013 and more recently in 2021 to reflect all of the new therapies that are coming through from industry, and to help better inform post-marketing surveillance for those therapies. So what we see is that the data sets that we had and published some years ago have needed to be expanded significantly because the type and range and detail of information and data that pharma companies and researchers require is much greater than previously.
Grazie mille. Sì, i registri sono una risorsa.
Thank you. Registers are a very valuable resource, and this is a contribution that all patients can give to the advance of research, to furthering research, because with a periodical update, which is no big feat, I don't think, it is possible to contribute to better understanding this pathology. And from there, we can definitely glean a lot of valuable information. So thank you very much for that. Gloria, we have another question that's just come in. Yes, for Francesco Millozzi. It says the use of nanoparticles is a strategy widely used in modern day therapy. Are they part of an approved therapy actually? If so, in what context? How many oligonucleotides could be conjugated with a gold nanoparticle? Good morning, everyone, and thank you for giving me this opportunity. And thank you for the question. The use of nanoparticles has already been approved by the FDA for clinical purposes, for medical use, especially in the field of oncology. We especially use gold nanoparticles, which have a lot of characteristics. For example, they can be used alongside many molecules like microRNA and different therapeutic molecules. And they have low toxicity. Recently, they were administered in clinical phase 1 and 2 to treat cancer in particular. I hope to have answered the question. Yes, thank you very much for that. Dr. Millozzi, for being here, for connecting. And now we'll move on to a question for, you know, that this poster session, had it been live, would have been more limited, but now because it's virtual, it's open to young researchers who have competed for an award that we will be assigning later on. And we've opened this virtual session to companies. Some of them are here with us, and we thank them very kindly for having sent their contributions and for having adjusted to the virtual format. In addition, of course, to sending their contributions, as I said earlier. I'd like to read out a question for Edgewise.
Che sentiremo anche parlare domani. E una domanda per Joanne. Sappiamo che è un trial per la distrofia muscolare di Becker.
We know it is a trial for BMD, so there is one immediate question. So how long will it take for you to come to Europe and Italy? And the other question is, can your molecule be used also for DMD? Joanne, you have the floor from the US. But maybe it takes slightly longer to connect with the US.
Hello.
Okay, Joanne, ti sentiamo.
I missed the question while it was promoting me to be able to answer it.
Ok, non ti preoccupare.
La possiamo rifare quindi la domanda.
Sicuramente, te la rifaccio, va bene?
So I can ask the question again. Can you hear me? Can you hear the English translation? Can you hear the English translation? Can you hear the English channel? Joanne, can you hear me? Since it was a trial for BMD, since your trial was for BMD, the question is, in the future, are you considering the possibility, even in a faraway future, are you considering translating, shifting these trials and testing also on DMD, so on Duchenne muscular dystrophy? And then as for your trials with BMD, are you considering including Europe and Italy? This is the question.
We are planning the Becker Muscular Dystrophy study to start in the first half of this year. And we are planning for it in Europe as well as in the United States. We do not have Italy, unfortunately, right now for the Becker study. We will likely be having an additional study after this. This is a study that is planned as a phase 2 study. We also are planning that to start a study in Duchenne muscular dystrophy. Because of the mechanism of action of protecting the fast muscle fibers, we believe that this is also applicable to Duchenne. And we are planning on a study the second half of this year to begin. And certainly, ultimately, we plan to expand the phase 3 in Europe as well. We have not made decisions on countries yet. Thank you for your interest. Appreciate it.
Grazie a te, Joanna.
Thank you, Joanna. And see you again tomorrow afternoon for the session when you are going to present your data. There is another question for Alessandra Rizzini. She's a young researcher for La Sapienza University in Rome.
Allora, ci chiedono qual è l'effetto.
What is the effect or with the treatment with HDAT and how the expression of TRIM2 is regulated if you already have specific HDAT for some type of repetition and not for others. I'm sorry, but the audio is not very good. It has a protective role in the dystrophic muscle, keeping the repair mechanism of the muscle membrane active. And we have seen that without the ACT4, this mechanism is no longer efficient. We have seen HDAC4 keeps or rather increases the stability of this protein in the repair mechanism, stabilizing RNA messenger. At present, we don't have specific drugs or therapies available which HDAC4, but we want to demonstrate the importance of HDAT4 and its prevention role and increasing its expression in the dystrophic muscle to help in the integrity of the muscle. In the long term, we hope to propose a specific therapy. It was a very long and complicated question. I've tried to answer. There is another question for Mr. Verrucci. Well, we must try and speak slowly because our translators have been working since this morning, translating into English and Italian, so that also our friends who are connecting from outside Italy to follow. The question for Mrs. Verrucci. The ANAC expression is present also in the skeletal muscles or only in the heart? Well, we are concentrating on the heart, but scientific literature, ANAC seems to be involved also in skeletal muscles, but this overexpression has been studied by us only in the cardiac tissue. Thank you. So it means that there will be a second part, a second possibility of research work where we will be studying the skeletal muscle, maybe in future years. And next question. Just one sec. We are almost there. We have invited young researchers to participate in a sort of contest. So there will be an award for the best poster. We hope to find all these papers. We had 19 participants, and thanks to the precious participation of Francesca Ceradini and Cinzia Bencivegna, we could study all these papers that had the idea of well, making the topic accessible. Thank you, Francesca. Thank you. I'm very glad to see the parent project family. As Gloria said, we had 19 of these papers that we studied. Many of them were very good, but we selected 2 of them, trying to give the award on the basis of the clarity and also the accessibleness. And so the winners are Bricida Boccanera and Laura Salvatori. Congratulations. You both had a cartoon. The cartoon was very good, very original. So Brigida Boccanegra is a researcher with the Professor De Luca in Bari, and her cartoon, the cartoon was very good from the graphic viewpoint. The title of the cartoon was New Metabolic and Epigenetic Modulators in DMD, to explain in a clear way the study carried out at the Department of Pharmacy and Pharmacological Sciences at the Bari University. Laura Salvadori is a researcher with Guglielmo Sorci at Perugia University. And again, there is a cartoon, and the title is Certainly Self-Support, the Proliferation of Myoblasts, Keeping Their Myogenic potentials, they have antifibrotic effects, and they induce the excretion of utrophin in myotubes, regardless of the mutation, to explain in an original and accessible way the study that she had carried out at the Perugia University. I like to add one little thing that, well, we like the two cartoons very much, and that next time careful for the title, for a take-home message. I mean, the title maybe should be shorter, but it's just a piece of advice. The cartoon was very good. Maybe the title should have been slightly simpler to make the whole thing accessible. If we had been in a face-to-face conference, you would have received a big clap of hands by the audience and by us, because we know very well how difficult it is to summarize in a simple way, in a simple and clear way, informations that are so complicated, so complex. So all the young people who participated, who accepted our challenge, well, they deserve our congratulations. And for you, special congratulations for getting this award. They are telling us that you can share with us your screen. Maybe they can do it from the technical direction. Well, congratulations to Laura and Brigida. Believe me, the jury was very strict, extremely strict. They were all extremely strict, believe me. And so congratulations. And it wasn't easy to make the choice. There were very many inputs, and many of them were excellent. And we were very happy to give this ex aequo award. So we divided the prize in two, because it was, in our opinion, it was appropriate for both of you to get the award. And I repeat what Francesca said. I share her opinion. They were both excellent works, but next time, please, a shorter and more understandable title, because the title should really be part and parcel of this take-home message, so make it simple. I know that sometimes going from the lab to, let's say, real life and writing, I mean, not writing a scientific paper, but writing something that is understandable for patients, families, and a larger audience is not something that is easy, and it can't be learned overnight. I mean, your work, your constant and hard work that we know very, very well, in your work in the lab, you were able to summarize, synthesize it with these cartoons. And when all the problems of the site will be overcome, of course, we'll leave these two cartoons there, so that you can everybody can read them. All the questions, we cannot answer all the questions, but we'll be sending you the questions so that you can answer both patients and families. Now we'll be sharing your cartoon, Brigida Boccanera. There you are. It is a cartoon that is really, really very good. Maybe you can tell us the story, what the cartoon is about. It is, I mean, this comics is really very good. Well, good morning, everybody. Thank you for this opportunity. We are analyzing new possible pharmacological targets for DMD. And I've tried to explain in the simplest possible way a pathway that is rather complicated. We still don't know much about it. So investigating the role of this kinase MTK, since I'm close to the world of video games, I decided to make this a short introduction with Batman. And I tried to reproduce graphically all the actors of this pathway and representing them so that they could be similar to the function they play. So the kinase is active upstream. So I represented it as this scientist that has a remote control in his hand, so he can activate the protein downhill, and that is accompanied with with the other proteins, and they have the initials on their T-shirt, on their overall, and then representing what we have discovered in mice in activation, or rather downregulation of the substance and its friends, and also the gene that is controlled downstream, and so it controls the sedation mechanism accompanied by an oxygen cylinder. So of course we are not stopping there, and we'll keep investigating this pathway and other possible modulators. So next year, maybe the cartoon will be going on. So we are waiting for that. Thank you. Thank you very much indeed. And we see Laura. Laura in Perugia. She's of the Sorci group. So it's very nice. Sara, would you like to tell us something about how you imagined it and what was your source of inspiration to translate your lab work into this?
Thank you, everyone. Thanks very much. It's a great pleasure. With the valuable cooperation of my colleague, Sara, this year we decided to present more innovative data concerning our Sertoli cells that you have known for years. And we decided to put ourselves out there. We tried to present data concerning Sertoli cells used in healthy patients and DMD patients. And we tried to actually come up with these cartoons to draw the attention of children and get them to have an interest in our world, the world of science, because people often think that it's extremely difficult to get into the scientific arena. So we transform the Sertoli cells and the cells in the muscles of DMD children in cartoons. We included ourselves in there because they're very truthful. They really do reflect who we are. We try to get across to children what it is that we do in our lab with these two different types of cells and what we analyzed and observed. We realized that Sertoli cells, all the substances that they release, have an action on different types of actions on myoblasts. These myoblasts are able to survive longer. They reduce the green cells, which are fibroblasts, which instead would prevent myoblasts from developing nice sturdy cells, and they allow myoblasts, once they have formed these large cells that contracts, to express a protein which is closely related to dystrophin, which they don't have, so that they can contract more easily and have less damage in the muscle. And we're talking about children. So with SARA, what we tried to do was to have families, but especially children, understand that science is not so difficult and strange. What we do in the laboratory is rather simple after all, things that everyone can understand. Thank you, Laura. I couldn't agree with you more, especially the last thing you said about science needing to go out of the lab and getting into schools and going everywhere in society so that it can be loved and appreciated by all. We now would like to give the floor to Silvia Bencivelli, who is connected here with us. To hear from her contribution to the poster session. Thank you. It was really very interesting. This is not the first time I work with you. It's always been very stimulating to see how researchers, young researchers, how they explain a difficult subject to an inexperienced audience and how they mainstream difficult concepts. This year, it was rather difficult to decide who to award the prize to, because we had wonderful written manuscripts as well, but we decided to reward images because they were a lot of fun and they also contain really important concepts. Brigida says science continues. Yes, I thought that the idea of cartoons was a really effective tool to get the message across. And somebody just spoke about communicating with children, especially now in the post-pandemic world. You know, we need to talk to our young people and children and explain things as, for example, why they should wear a mask. But images are a habitual instrument used by scientists. I mean, Galileo used to draw moons, and the scientific revolution is really based on a lot of images. So those researchers that chose to communicate using pictures and images opted for something that is quite natural, because average scientists are accustomed to thinking in terms of images. I mean, a lot of scientific papers contain many images, so choosing to use images and pictures to communicate to others made it easier. It was a smart choice because for you, images are truly everyday tools, so you were able to do a good job. So we awarded two and not just one cartoon. That's why I want to encourage researchers not to think about the fact that pictures are a way to water down or degrade a scientific message, but that images go along with the language of science. They always have done, and they, as human beings, we really do attach a lot of importance to visual messages. So well done, and well done to those who decided to rise to the challenge of writing a fairy tale. Bravo to those who transformed a scientific poster into something that's more mainstream. So please keep it up, because this is really good for everybody. I think it'll help you find meaning and significance in what you do, because what you do is really important to everybody. And if you recognize that, maybe you'll do it even better. Thank you, Silvia. We completely agree with you. Of course, this is one of the first opportunities for these young researchers to rise to the challenge of mainstreaming scientific information. And as Sylvia rightly said, keep it up. We will always be out there to stimulate you. And next year, I'm sure we'll be overwhelmed with cartoons. Everybody will be sending in cartoons. I agree with Sylvia. And you did a good job. You drew them very nicely, so why not? Well, in 2023, we'll open up a store selling scientific cartoons. Well, what about videos? What about videos? We don't have anything in that regard. Yes, that's true. Hopefully we'll meet in person because it'll be a lot more streamlined to view videos in person. Or a podcast, an audio product might be interesting too. I'm sorry, she's got nothing to do with what I'm saying.
I podcast assolutamente, noi li aspettiamo, magari sarebbe fantastico.
That would be fantastic. It would be great to share them on our website. It's a wonderful idea. I do wish to thank, first and foremost, Fernanda De Angelis and Ilaria Zito, who devised this poster session together with me. It should have been in person. You could have discussed your posters holding a cup of coffee and talking to people, but that wasn't possible. We will do that in 2023. Once again, thank you, Sylvia and Francesca, members of the panel. I'd like to thank all participants, all the companies that joined us in this session, and of course, all the members of the team. See you next year for the poster session, but see you after lunch for the session that will discuss clinical trials. We talked about research yesterday and today. We talked about lab research. But in the afternoon, we will open a session devoted to trials, starting with gene therapy, which is quite recent. It's very interesting and promising. Thank you, and see you a bit later. Bye-bye.
Grazie.